Okay guys, in this video our goal is going to be able to set up this triangular situation using bearings but also rates and times. And so let's go ahead and take a look at this situation. It says two ships leave a port at 9 a.m. One travels at a bearing of north 53 degrees west at 12 miles per hour and the other travels at a bearing of south 67 degrees west at 16 miles per hour. What we want to do is approximate how far apart they are at noon that day. And so I think it's good to see something like this set up just one time so you get an idea that all we're really doing is trying to cast these directions with certain lengths here using our rates and our time. So let's go ahead and start with this. We'll call this point right here kind of like our port. And so I will label my picture here port. But the fact is our boat's left from this point right here at this port. And so what we're going to do is, because we're using bearings, we're going to pass a north-south line through it, okay, but also an east-west line here. We're just going to kind of map out our directions. I'm going to say north, south, east, and west. And so first things first, it says, well, our first boat left with a bearing of north 53 degrees west at 12 miles per hour. So the first thing we want to do is just establish what direction this is heading in. So if I'm north 53 degrees west, this means we're going to start up north and we're going to deviate 53 degrees towards the west. So I can almost imagine that this might look something like this here, where this angle that we see right here is 53 degrees. So we started north and went 53 degrees towards the west. Now, in terms of how far this has gone, the thing is we were told how fast this ship was traveling, 12 miles per hour. And so why this is an advantage to know is because, remember, from, I guess, 7th grade earth science or science class, distance is rate times time. So we're given a couple bits of information here. If we want to find the distance, we need the rate and the time. And so our rate is 12 miles per hour, meaning every hour I go 12 miles. And our time would be the amount of time it takes us to go from 9 a.m. to noon. And so in 3 hours, how many miles would I go if I'm going 12 miles per hour? Well, I would say this is 12 miles per hour times 3 hours. I'm going to go 36 miles. And so we're going to label this side of our triangle here 36 miles. And I apologize for those two numbers colliding there. As a matter of fact, what I'm going to do is I'm going to go back and I'm going to try to write it here, 36 miles, you guys. Okay, so now the next ship, we say, well, where was it heading? And I suppose that it was heading south 67 degrees west at 16 miles per hour. So when I draw this one, I'm going to draw it a little bit longer than my 12 mile per hour line just because it's going a little bit faster. And I'm also going to start south. We say south 67 degrees towards the west. So I can say that, you know, south 67 degrees towards the west would rotate quite a bit here, maybe something like this. And so I would say that this is, right here, starting south, 67 degree deviation towards the west. And so what we end up with is also something where our distance here would be equal to our rate times our time. 3 times 16 is 48. And so this would have gone 48 miles here. So in terms of 48 miles, now let's look at the question we're being asked. It says, how far apart are they on noon at that day? Well, this distance right here would really represent the third side of our triangle, but also the distance that we're trying to find. And so the question really becomes like, well, could we go find this distance? Now, we do know two parts of this oblique triangle right here. If we had any angle side pairs, then we would be able to go and use the law of sines. But just because I don't know this angle right here or this angle right here, we're not going to have any angle side pairs. Because I'm also, even though I'm going to be able to figure out this angle right here, I'm not going to know D across from it. So we'll have to use the law of cosines here. But it is in terms of these two angles that I wanted to look at. You know, what would these two angles be right here, or at least this angle right here? So the way we can do this is we could say, well, if I know that I went south 67 degrees west, then to get me completely over to west, I would have gone 90 degrees. So if I take 90 minus 67, then what I get is 23 degrees right here. And so this bottom part is 23 degrees. I could also say if I went 53 degrees towards the west from north, then this leftover part right here would be 90 minus 53. So 90 minus 53 degrees there is 37 degrees. So what this means is that this entire angle would have to be this 23 plus this 37, which really gives us 60. I think I'm going to redraw this situation now and say that now I really know that this is 60 degrees and that this is 36 miles and that this is 48 miles and that this is the distance that I want to find over here. So as we do, as a good habit, we tend to label these things out. So we'll call this, how about we call this little a? We'll call this one little c, and then we'll call this one little b. But what we want to do is go find b. And so because we don't have a side angle pair, what we're going to have to use is our law of cosines. But because I want to find b also with our law of cosines, we're going to use the format or the form of law of cosines. It starts with little b here. So we're going to write this out first. B squared equals a squared plus b squared, very Pythagorean, minus 2. Now I've got to multiply these two side lengths that I just used, a and b, times the cosine of the angle across from where I started here, which angle across from the side length that I started with is angle b. So plugging everybody into this, we can see that I get b squared equals a squared. This is going to be 36 squared plus 48 squared minus 2 times 36 times 48 times the cosine of angle b, which we were able to determine was 60 degrees here. So with the rest of this, basically what we're going to do is just get a value here. I'm going to type all this in. I'm going to say 36 squared plus 48 squared minus 2 times 36 times 48 times the cosine of 60 degrees. And so what we get is 1872. This doesn't always happen that it comes out to be an integer, but we say b squared is this. So our b value here is going to be the square root of 1872. And usually we'll get a long decimal here, so we just hit square root of second negative key to get my answer. So about 43.27 units in length here. And in this case, we had units of miles. So this is a good example just to get you sketching this in the first place, but using what you already know about those initial angles in your north-south line to figure out what might any of your interior angles in your oblique triangle situation be. Cheers.